Okay, well, welcome everyone to this morning's final session, I believe, which is the use of GeoPose and other standards, and to some extent, the relationship between GeoPose and the use of similar concepts in other standards.
Could you speak more clearly into the microphone? Thank
I will. So the core idea of GeoPose is that it implements a representation of something that's pretty simple conceptually. A location and an orientation, or you can think of it as the pose of a camera from computer graphics. It's simple. In the standard, it's documented in enough detail that it's easy to test whether your implementation matches the conceptual model and the conventions that are used in the GeoPose 1.0 standard. You can use it to avoid reinventing the wheel in your standard. And we hope in the future that you will be able to use pieces of the representation to represent pieces that correspond to things like position or orientation in your standard. So the idea of GeoPose is simple, and our approach from the beginning was to make it both natural from a human point of view. So our default, our simple, our basic implementation is one that assumes a horizontal plane and orientation with respect to north and east. As we've heard discussed in previous sessions, this breaks down sometime. For example, if you're at the North Pole, but in general, it corresponds to people's feeling of being on a flat Earth in normal experience. So we're going to have four presentations today, and it's from a different a variety of points of view. So again, so the relationship between things that are happening already in other standards or other proposals, the inclusion of GeoPose as part of these other standards, and perhaps some conflicts between GeoPose and elements of these other standards. So we're going to start with a presentation on the interworld portaling system, and it's going to be presented by Greg Billum, who's present, and Alfred Tom is online, I believe, and is available for comment.
Hi, everyone. I'm Greg Billum. Give me a sec here. I just want to take a look at something. Is there a way to do speaker notes?
No.
All right. Well, I'll wing it. I had a lot of extra detail in there. All right. So I'm Greg Billum. I am coming from Sunset. That's the company that I run. I'm also with the MSF, the Metaverse Standards Forum, and OMA3. At OMA3, I'm a co-chair of the Digital Assets Management Working Group and the AI and Metaverse Working Group. at both of those, I basically assist in nailing down standards in terms of what's out there. We're not really responsible for defining standards, but we do work on use cases and work with a consortium of people together to define what is necessary. Today I'm going to be talking about GeoPose-enabled metaverse interoperability and how to integrate geographical positioning across open metaverse standards. So today we're going to explore 4 different projects, and like I said, it's an industry consortia, so this is different groups working on different projects, but I am kind of involved in each of these, so I do know what's going on behind the scenes, as well as how to integrate GeoPose into them. And so I'm just going to jump straight into this. I think I have about 5-10 minutes. So the interworld portaling system, the Metaverse Universal Manifest, the Metaverse Metadata Directory, and the Peer Mesh Open AR Network. So the first one, and the one that was on the initial slides, include the interworld portaling system, which is an API specification enabling. Oh, thank you. Perfect. Yeah.
Next one.
I'll just go for this. It's fine. Okay. So yeah, so we have an API specification for enabling seamless teleportation of users, their identity, their assets between different virtual worlds, and we're basically there's a challenge here in interoperability and using the metaverse, where you really want to be able to jump between these platforms, and without being able to jump between the platforms, it's basically a closed walled garden experience, and you're not actually in a metaverse. You're in somebody's standardized game environment or simulation. So it's important to be able to jump between different worlds, and to do that, you want to kind of go through a portal, come out the other end, and be facing in the right direction. So that's where GeoPose really makes sense, is that you want to be staring at the right thing, especially in a crowded environment where you might be entering a domain with other users. You really want to be able to see where you're at and record that, and GeoPose is great for that. I think in general, all of these standards really need to lock in on a standard and use it in terms of specifying their positioning in coordinate space. The Metaverse Universal Manifest is the second one I want to talk about. It's essentially user-owned decentralized metadata. When you jump between different platforms, or you're going between portals, what you really want is a way to carry everything with you, like a briefcase with your assets, your preferences, your preferred, language, what DID you might have with you. Right now, there's no way to move between metaverses and have an identity. So at the Metaverse Standards Forum, I co-authored this Universal Manifest in order to solve that problem. And in that, you would really want to store your position history over time. So you want to be able to say, I was wearing a pair of AR glasses in the hall down the road, and I walked through a virtual portal there, and then I, brought some other people with me, and you want to have a sort of historical evidence and trail of where you went, and your positioning is really important for that as well. So Metaverse Universal Manifest is another standard, and it's kind of surprising to me that this stuff hasn't been defined up till now, and we're kind of looking at this. The reason why the metaverse hasn't taken off is that you do need this interoperability, and at the core of that is position. So the MVMD is the Metaverse Metadata Directory. and it's a framework for integrating multiple metadata standards to make metaverse assets complete and discoverable across platforms. The idea would be you would have an object, and that object may be in a location or not, but what you want is a schema that defines everything for your positioning. So you have, you might have an object as a GLTF file, and you're using it with a USD film pack, and you're bringing it into a virtual world in, Unreal or something like that. And you also want to define your positioning. Well, that's 3 standards packed into one file. And so that's what the metaverse metadata directory hopes to do, tackle, is a sort of opinionated way to define location and the elements you're bringing with you. And so that's the core of that. Works with schema.org, one standard metadata across all platforms. Pure Mesh is the final one I wanted to talk about. It's a distributed network infrastructure. So this is the infrastructure necessary for having a wireless network system that's on your device, data sovereignty, and control over your information. It's going to be really important as we move into this world where everyone's wearing AR glasses, for example. And Pure Mesh is a standard or a set of components and a group of open source teams that kind of build stuff together so that you don't have to keep rebuilding the same stuff over and over. And a lot of that is about defining standards and using them, and then everyone can borrow from them. And that's pretty much it. So GeoPose enables the open metaverse. It serves the foundation for enabling 4 key standards to create seamless interoperability, user control, and open infrastructure across the metaverse. Seamless teleporting, bring your discoverable assets with you, being able to define objects with multiple standards, including GeoPose in one object, and being able to code and develop a network of open metaverse platforms. And that's pretty much how it all wraps together. So, any questions?
Could we see if Alfred has anything he wants to add?
Yeah, Alfred, are you there?
Yes, he's.
I am here.
I'm sure I missed something there. I think maybe I misspoke on the portaling.
No, I think you did a great job.
Okay.
Yeah, GeoPose fits pretty seamlessly within IWPS, the protocol. The exact implementation, we have to still, decide within the working groups. But I think it's a good fit.
Oh, no, thanks for that. I think you've highlighted, I think, the elephant in the room between all of these. The fact that you've got the standards and they're trying to sort of harmonize is awesome. The elephant in the room is, how do we define position? Because that is a complex beast, and I think that's something that has to be addressed in a very interoperable way of how do we create a standardized way of moving or translating our concept of position between these different worlds. So that's something dear to my heart, but it's a real challenge.
Yeah, I agree. And we were talking about positioning of a device in 3D space, but if you're talking about entering through a portal, you're talking about your face and where you're looking, not a third-party device you're holding, which is another complexity here. Is how do you interpret something when is it the third person or first person point of view that you're dealing with? Where's the positioning? really making sense.
We'll have some time at the end. I think we need to go on now. But I've bookmarked Chris and Greg, the last thing you were describing, or actually maybe it was Matt, who was actually thinking about the time and not the people. It is this. Bookmark. The next speaker is George Percival from the Spatial Web Foundation, who's going to talk about incorporating GeoPose in his standard.
Thank you, Steve. Yeah, this is George Percival, and online with me is Stefan Fella, also from the Spatial Web Foundation, and I'm going to talk to you about spatial web. So Spatial Web Foundation, first off, is about agents that are in a cyber physical world. So the ability not only for virtual agents, but physical agents, and the ability to go across those kinds of different spatial representations, anticipating a lot about autonomy of those agents, whether they're humans or they're, artificial agents. So that's kind of the scope. The strategy is to build, use the design pattern that the World Wide Web made very well known to us and expand upon that. So the primary objects in the web are hypermedia documents, right? It's all about accessing documents. In the spatial web, it's about cyber physical entities, and I'll give you a little bit more about what I mean by entities, but they are real world and cyber world entities. HTML is the way that you do markup. HSML, which we'll speak about, is a modeling language for hyperspace modeling language. So the ability to model things in hyperspace, things like the cyber physical entities, a protocol for exchange in a distributed computing environment. So a hyperspace transaction protocol, again, parallel to HTTP, and then addresses in spatial domains. So domains is the entity, the feature. We reuse that geographic term of feature when we start to describe things about domains and the way things in space have some meaning, have some semantic content and the like. Those are the domains. It's approved as a IEEE standard as of May this year. You can go find this. Right now, they still charge for it. That'll be changed soon. So there's an existing standard that's been approved through IEEE for this talk. So the entities, modeling entities in the real world, cyber physical entities is this ontology, if you will. Starts at the bottom with, guess what? The basic framework of cyber physical is space and time. And I meant to say time, Chris, time. So, and we actually extend that with the notion of spatial embedding to very high dimensional spaces. So we're now able to address, thousands dimensions in spaces that have semantic meanings. LLMs have done this for us. We've got some really good technology to do that. Concepts that persist over time. So from an ontological point of view of what exists over time, throughout time, and have identity, those are the domains. And so we too, I think, Greg, you mentioned DIDs. We use DIDs as spatial web identifiers, which is not universally done, but we think they are very critical for distributed identity, and so we use DIDs. Concepts that describe change. So change throughout time. Agents have the ability to affect change in the world, and they do that through activities, and coordinated activities between agents becomes that relevant. And then governance, the ability to have some objective normative world in which these agents live, and they adhere to norms and contracts and credentials and laws is the top side of that. And HSML then encodes these entities of this ontology. With respect then to GeoPose, within the approved IEEE standard is a statement that says spatial web shall enable the use of GeoPose. So it calls out the need to use that. It's in the normative references. It calls out in particular 1.0 Probably should update that as we move forward. And Stefan is currently evaluating how to meet this requirement by putting GeoPose and HSML, semantic modeling language for the web, modeling space. In fact, I think we've got a whole slide here about HSML. Stefan does a good job of putting 4 slides into one. So where somebody said earlier, there's a lot of words on a slide. Now there's a whole lot of slides on a slide. But I'll let him defend himself in a minute, Stefan. You'll get your chance. So, you know, there's a lot in there. And in particular, RDF stack that makes this up. And the architecture, the modular architecture that's being defined right now for the HSML implementation spec, a separate spec from the IEEE one that I mentioned. So in particular, agent situation in HSML. So a situation of an agent is, what is the world that's around it right then? What are the other entities that it sees looking in a given direction? What is my context is essentially what a situation is. But a situation is an entity that the IEEE robotics community has strongly defined and gives a real good, strong definition out of 7007. So a use case for this is to compose a situation, which is a list of domains that are relevant to an agent at any given point in time and space. That is the entities in space that are bounded by a GeoPose. And so the HSML situation would be an RDF version of GeoPose, which is the current need right now to develop that. So I think I've got one last slide, which is to say spatial web made it on the Gartner radar. This is very recent, but they also break up spatial AI into a bunch of different, I forget what they call them, the individual icons within their radar. From a spatial web point of view, HSML is a trend on its own. HSTP is part of the spatial web protocols. UDG, which is another, it's the universal domain graph of the spatial web. It's in the systems, and they recommend experimenting with HSML right now. So that's what I have. Stefan, fellow, what do you want to say about HSML briefly before we see if there's any time for questions?
Yeah, the HSML is kind of the spatial web in general is kind of a generalization of RML because we are going beyond the familiar 4D space by introducing hyperspace. The domain can be seen as Olen, they can be seen as whole and part. And each Olen, each domain, they can have one or more hyperspace definition. So they can have multiple coordinate systems. And the GeoPose will be basically attached to the entities that are within this domain. And they will be always relative to the parent domain reference system, reference frame. So it is a kind of embracing the GeoPose chain, but in a way that is implicit to the construct of a domain. We don't have to really formalize the chain the way it is done in GeoPose, because every pose will be always attached to the thing relative to the frame of the domain it lives in. So that simplifies a little the model, but the plan is to get the quaternion and the encoding of GeoPose aligned with what is in the spec, but it will be encoded in RDF explicitly. So that's it.
Thank you, Stefan. Appreciate that elaboration. Where are we going? Time for questions or move on?
Questions at the end.
Questions at the end. Okay.
Thank you, George. The next presenter is me, Steve Smith. So this is actually going to be pretty brief. It's a proposed extension to Chronos GLTF to, in as simple a way as possible, define a standard way for attaching a GeoPose to a GLTF file. And Oops. Oh, never mind. So there's a bunch of words here, which are in white, and Ali is going to make them the text color black so we can see them again. There we go. And so this really summarizes it up that GLTF scenes. So GLTF is essentially a collection of scenes, and scenes have a bunch of subparts. So GLTF is a representation of a scene graph in the strict computer graphics sense. And the extension is to link the scene graph for each individual scene. So a GLTF file can consist of more than one scene, often just one scene, but it can be more, to link the scene to a position and orientation. Sorry, that's my notes to myself. So at the moment it's called EXT geolocate orient bound. It is an extension to GLTF, as I described, attaching to the scene. It's a draft. It's essentially coming from the GeoPose standards working group in OGC, although it's not, that affiliation doesn't show up very clearly in the submission to Kronos. It also provides bounds. So you might wonder why have bounds? And the bounds came from several use cases where, in particular in visual positioning, one way of making money with visual positioning is for mobile operators, when they implement 6G, to put their own visual positioning into their edge computing capability. You could almost think of this as you have the cell towers, the location of the transmitter receivers that connect to the internet or to the mobile operator's private network, but hardwired as a place where there would now be new computing capability, and that the mobile operators would sell services based on this capability. And so it's going to likely, in this scenario, be organized by the same tessellation of space that mobile operators use for their transceivers. So having bounds defines what is the spatial and, in a moment, time, temporal bounds to the usability of this service. And this presumes that there's some discovery mechanism so you can find a service that's within whose bound you are located. So one of the use cases that we're considering is a related thing in OGC in the CityGML. So CityGML is an urban modeling representation, buildings and trees and signs and roads, rivers and tunnels and bridges, all of that human-built infrastructure. And one project that's been proposed, and maybe we'll go forward, since there are hundreds of millions of buildings published in CityGML, to publish them in GLTF to make them more accessible for visualization, and to use this extension to attach a position and orientation to each one of these hundreds of millions. There's an awesome CityGML GitHub repo, which you can go to see the hundreds of millions of buildings. So Kronos has a pretty interesting way of characterizing proposals, and it's at the stage they call idea. Christine might have more insight into how they came up with these names, but essentially,
I can tell
oh, okay. Thank you.
you. Yeah, I did put my hand up.
Yeah, so I'm the co-chair for 3D assets, not 3D graphics. Thank you. I get confused. I'm sorry, Amanda Morgan. I'm the co-chair for MSF 3D assets. I'm the co-chair for Kronos GLTF 3D as well. So Amanda Morgan, nice to meet you. So actually the GLTF process to get an extension through, if ratification is the intent, if EXT is desired to be ratified, that process actually was just recently updated at the Kronos face-to-face, which happened last month in Philadelphia. So that should be much better defined now and should not be as ethereal as has been previously done. And as far as like idea, I think it's really more, I don't, I haven't actually looked at this. I do wonder if you have looked at the GLTF 2.1 proposals for complex scenes, because especially with City GML and the building of complex scenes, with the intent to do that within GLTF in the near term, how this would be impacted by that, because there's obviously some play at how those work together as opposed to doing it in GLTF 2.0. But we can have that conversation later. But anyway, so as far as the new process, I highly recommend, we're in the comment section right now of getting feedback on that process and would love to hear your feedback within Kronos and GLTF.
Thank you, Amanda. So our intent was to get something done quickly and that was actually useful. And one of the things that came out of the initial study of the old version of the process was that it would be highly useful to have an implementation that actually did something that people would find useful. And what we came up with is an app which will allow you to specify a GeoPose and have it correctly change an existing GLTF file to include reference to the extension as well as the correct information using the extension to geolocate one or more scenes within a GLTF file. So with that, I think I'm declaring myself out of time.
One more speaker, Johannes there.
Yeah. Can you hear me?
Yes.
Excellent. So would you run the slides? Lovely. Okay.
I think I am. So tell me when you're done.
Excellent. So I'm going to talk. So my name is Johannes Beer. I'm the co-chair for the 3D Web in Europe forums group, and I'm also one of the founders of 3D and had written or have worked on a couple of Kronos standards, and I'm also in the Web 3D consortium. So especially large-scale web application with industrial data, that's what we are really do. And there we always use open web standards and try to leverage open linkage and open web architectures. And that's what we would like to expose here. So next slide. So Web of World sets right now exposes worlds and assets, but not any georeferences. So the worlds and assets, the aspect models really just interface information so you can connect between these worlds. The core idea is to enable really links between worlds and assets, and those APIs try to expose the necessary information. So no geo references, even though some of the use cases already use geo data and geolocations. So some of the world assets have hidden data states that could be exposed, including geo information, and we propose right now an extension to the proposal where we allow GeoPose information to be extended or included in your asset and world data. So next slide. So the overall structure of this solution is pretty simple. So we really try to build on a web idea that everything that is addressable, so has a unique URI, a persistent addressing space. So every world lives on a standard web and can be addressed. So the world itself and the asset are entities that can be exposed in this web. And then there are a couple of requirements. So you have to be able to experience this world on a given device by opening in a browser. So the system must be able to actually choose a technology that fits to the device and everything. So that's something we're working on. But the general idea is really that you just link between the worlds or assets, and this allows you to really build this web. So the whole idea is really about, so we expose spatial information, but the whole grid, like the 2D grid, does not implies a given addressing schema. So it's really just about how URLs work together. So next slide. So therefore, the core idea is really that we have an abstract definition of a single world that contains a certain number of worlds, users, views, portals, and scene data. And the scene data, again, references locally nodes with local transformation that can point to assets or additional worlds that are then expose a representation that can be linked to the world. And that's something that we use. This is a very simple but proven pattern that allows us to build this distributed environment. And on the left hand and on the right hand side, there's this worlds and asset that is really part of this definition. So in the VOV API, we have something like an open spatial world API where we have a Swagger definition, so open API definition that contains JSON schema that actually defines these different aspects. And we have exposed now, or have extended this structure. Next slide, please. With this GeoPose information. So right now, you can actually, if you join or if you follow a preview world, this means that you can really address a certain entity in your world, but you don't need any spatial information or any exposed information. You just can there join a world, and this means that the world itself must provision a web application that can then really deliver the data and can use whatever is used as technology underneath, so it can use tiling or whatever is actually hidden in the infrastructure. And then underneath, you can really have additional APIs that, for example, allow you to access a world or user information. And there, again, is a proposal that this entity, like a user, of course, is related to a view, and a view is independent of a user, so you can have views, and if there's no user, you can still have a persistent view that can be used for linkage between those worlds. And this is something that we proposed. So there are, like, one of the use cases we're working on where we have actually a factory from Mercedes-Benz where the data is actually then exposed through these APIs. And there we really try to load, then expose in this API the GeoPose as part of the overall structure that we provision. Okay, next slide. Yeah, that's it. So right now we just used one variant. So this first known to us position angle, but we also all have a computer graphics background. So maybe Quaternion is something is easier. It's also used in a couple of standards that we use, so we might switch. But right now, this is something that is already in the schemas on GitHub. So we talked to a couple of potential users. So we have some colleagues, ex-colleagues at Fraunhofer that look at this standard right now. So this is one of the first use cases that we built right now. And then we have a couple of use cases that, so 2/3 of our customers build cars. So a lot of the factory data that we expose in these spaces and data spaces is something that we try to use in this infrastructure. Yeah, so that's beginning, but for us, it's really a very useful tool, because before we didn't have, oh, sorry, there's 2 typos. But it's a very useful tool, and people ask us, so we didn't have any geolocation or any geo information in the virtual worlds right now. So the virtual worlds were just virtual entities, so no reference to real worlds. And now we have the ability, so it's not a must-have, but for us, it's something that it's an optional asset and world property, so people can then use the world. So it in the asset is really optional. In the most assets, people have assets from data spaces or other entities. So, and there they don't have GeoPoses, but in the world, this could be really a great use case.
Well, thank you very much, Johannes. We'll continue on with a few minutes of questions here. I've got some bookmarks in the audience, starting with Chris, and I'll bring you the microphone.
My question was actually going back to Greg's presentation about the metaverse manifest and the peer mesh. And it just struck me there's a big overlap with all this thing about personal information being private and under control of the individual. There's a big overlap with the SOLID initiative from the W3C. And I just wonder if anybody knew of any active collaboration that was going on. None. Okay. Yeah. Because the SOLID have meetings about once a month where people can just chip in.
Thank you.
Thank you, Steve. So, Greg, I'll apologize in advance. I might be coming into this conversation way late, but your talk, what I was thinking of is like, how does position in one world, in an inter-world portaling system, to take an analogy, how does your position in VRChat affect your position history or matter even, or is relevant even to your whatever you're doing in, let's say, horizon worlds? And so to what extent do we want to model position history in one world, especially when we think of GeoPose more as a global lat long altitude type of, and it does not necessarily relate real world to the virtual world and all kinds of contexts. So, I'll stop right there because it's just off at a tangent.
Yeah, to address that, I think there's a couple ways to look at it. There's the sort of virtual overlay, like a digital twin or something like that, where you would actually have a one-to-one relationship with the position in physical world. But you might have a base on the moon, and how do you define that? Or something in a virtual space that exists underwater or something like that. So, yeah.
Or two interesting spaces are, one is going through a mirror and another is same place, different time.
That's exactly what I was going to say. And there's two models there. One is the video, right? There's the time on the video, and there's a time you're watching it, and there's a time, and there's also weather forecasts. There's two times, and that's a digital twin. And so I think that's really important that digital twins recognize that they've got to have double coordinates. I ate them.
Yeah, I'll just mention to that that virtual versus physical is an important role for GeoPose, but we haven't really developed it. And the concept is analogous to tie points. If you're trying to geolocate, georeference an image, you pick things that are the same thing and they're on the image, they're a pixel, for example, or an object, and they have a position in the real world. And so that can be generalized to an entity with a GeoPose that you identify as being the same entity in multiple worlds. You get enough of those, then you can come up with both a positioning and an uncertainty of that positioning in multiple worlds, whether they're physical or virtual. But it's kind of a Pandora's box, and it's another direction that RML is going into.
Yeah, my opinion is you have to actually build things in order to find out what works and what doesn't work. I saw your hand go up first.
So, slight tangent on that, and then I'll go back because I think that's a really interesting conversation. In terms of the spatial web protocols, where are we at with clients that are readily able to understand and ingest WSML and WSTP? Is that the next thing that needs to happen, or is that actually doable now?
Actually, it's doable now and it needs to happen, right? So an SDK of both a client and a server for HSML and HSTP exist. The release of those is under development in terms of the stuff to do that. So talk to me if you're interested in SDK for HSML and HSTP. With respect to this question about tie points or discussion about tie points, which is one way of representing a portal, if you will, between two different worlds. So now we've got two worlds. One may be a physical world, one may be a virtual world. And the notion of using tie points is good. I hadn't thought of that, Josh. That's cool. But you've got that pair. The key thing that I think you're probably going to maintain on that is certainly in the geospatial world, you're going to use a coordinate reference system with a coordinate system and a datum to define the geospatial. In the virtual world, coordinate system's dead simple, right? I mean, USD has a coordinate system. It's Cartesian in some room that has no datum. So is there a datum in the coordinate reference system in a virtual world? and what would it be, and you know, that's what we've been teasing out. Yeah.
Is it constraining or is it liberating?
It's liberating. Yeah, because you're going from Cartesian to other types.
Yeah, but the datum gives you the semantics.
What?
The datum is the issue, not the, I mean, yeah, it's good, you might use Cartesian, but the datum in the virtual world, what does that mean?
Well, you could have a different space, not a Cartesian space, for example.
That's the coordinate system. What about the data? Yeah.
There is a constraint, right? And that's a mathematical constraint that on modeling, and that is to do with 8 dimensions, right? So as long as you're sticking with 8 dimensions and you're not inventing other virtual dimensions in your virtual space, you're fine. Because in underlying mathematics, and you want nice properties like arithmetic works, you are limited to 8 dimensions.
Where's this 8 coming from?
It's coming from Grassmann about 150 years ago, and also Clifford, who's a mathematician.
4 on each side, is that what you get?
No, it's just 8. 8 is a limit to the number of nice mathematical properties you can have and have a well-structured algebra.
So I feel compelled to add that in Stargate the television series, they either threw something through the portal ahead of them that they could use for navigation once they're on the other side. So that's like defining your own datum and then exporting it to the world. Or they sent a robot through that had a cable that came back to your space. So
for those online, yeah, Matthew Pearce again. This strikes me as a really interesting angle around discrete global grid systems, because it allows you to define a location in a semantic index fashion where you don't have the same complexity of datums that you do when you're dealing with coordinate expressions of position, and that I think lends us nicely to that a standardized and systematic way to describe a view of position between these different worlds. I'd be really keen to explore some of those things.
thank you. Thank you all for participating in the standards and GeoPose session.